Hello guys, so this is going to be the squeeze theorem re-explained, take number 2, because I apparently lost my words way too much, and let's hope I can do better this time. So, squeeze theorem, for this one I will actually be doing problem number 9, and basically using that as, from the exam, and I will basically be using that as the example problem on how to explain. So basically, number 9 states that we need to show that limit x approaches 0, and also you need just adds up. You always need to write this, because I forgot to do that on the exam, and I actually lost a point for that. Sucks to suck. And oh god, I just realized my computer is at half battery. That's wonderful. Anyway, so we know that the limit as x approaches 0 of x to the 4th times sine of 1 over x. We're supposed to prove that equals 0. Now, we can't just plug 0 into this to basically solve it, because if we can't just take sine of 1 over 0, since that's indeterminate. So doing that would be wrong. General rule of thumb is try to if you have like a fraction or something, a little shortcut you can do is you can plug it into the bottom of the denominator of said fraction and solve that, see if it equals 0, and if it doesn't, then you can go ahead and solve it like being plugged into the whole thing. But if it does equal 0, then that's when don't bother just trying to plug it in. Just a little life hack for y'all, a little bonus tip, if you will. So basically, we know that on the unit circle, I'm not drawing the whole thing, but this is basically a very crude drawing of it. But basically, we know that our maximum for sine function is 1, and our minimum is -1. And now, since sine will always travel on one of these points on this unit circle, so therefore, we know that sine of theta, where theta could be anything, we could even say theta equals 1x, 1 over x, it doesn't really matter. It will always be so -1 will always be less than or equal to sine theta, which will always be less than or equal to 1. Since we know that the absolute value of -1 is equal to the absolute value of 1, since the absolute value basically removes the negative sign but keeps the actual number. But if it's positive, then it stays positive, but if it's negative, then it turns to its opposite, which would be like this. So therefore, this would also be equal to sine theta is less than or equal to, no, the absolute value of sine theta is less than or equal to 1. Now, we'd have to do that for both terms, because we have to do it to the entirety of the term. Otherwise, if you don't add the absolute value to all terms within this, that you could potentially run into issues with the equation n no longer being equal to the original, like this part. So basically, we now have absolute value x to the 4th times sine 1 x. And remember, we're taking the limit as x approaches 0. That's, in my opinion, it's a bit obnoxious to write that every time. But honestly, it is what it is. So the squeeze theorem basically relies on the fact that if you have an upper function and a lower function, and then a middle function, where the upper function is always above the middle function and the lower function is always below the middle function, then that means if they come to the same point, the upper function is equal to the lower function, then the middle function must also be equal, since the middle function cannot go outside of the bounds of either the upper or lower function. And at this point, it would be at the origin, but this was not really drawn to scale. Just a quick disclaimer, that was kind of a crude drawing. Anyway, so since we know that, almost forgot that part, to bring that part down. However, we're gonna have, like this is not equal to this, because we did not have an absolute value here originally. However, what we can do is take absolute value of x to the fourth out of this little bundle. Don't forget that we're taking the limit as x approaches 0. And then basically from there, so since absolute value of -1 is equal to absolute value of 1, since we've taken this part out, we can then bring it over to the right side. So that less than or equal to x to the fourth. So now from there, we need to get rid of the absolute value here. So to do that, we'd have to take the positive and negative of the right side. Because from here, we basically just, like, moved it over to the right side, basically. Alright, so that leaves us with negative. And always remember to write limit as x approaches 0, even though it's very obnoxious. Not even gonna lie to y'all, I don't understand why that's necessary, but it is what it is. X to the fourth. So the negative absolute value of x to the fourth is less than or equal to sine of 1 over x, which is less than or equal to x to the positive absolute value of x to the fourth. So from there, this becomes our lower function. This becomes our upper function. So this right here becomes this right here. And then this one becomes this upper function. And then this sine of 1 over x becomes like our middle function. Oh, and oh, okay, pen. Anyway, you get the point. So from there, we can then plug 0 into both the left function and the right, the lower function and the upper function. So from there, we now have negative 0 to the absolute value of 0 to the fourth, and then just the absolute value of 0 to the fourth, which, if you take that to the fourth, 0 to the fourth is 0, absolute value of 0 is 0, and then you don't really have a negative version of 0. So that's so both of those basically simplify down to 0. And since 0 equals 0, therefore that means that sine of 1 over x must also equal 0, since there's no way it can go above x to the positive absolute value of x to the fourth, and it can't go below the negative absolute value of x to the fourth, as shown here. I hope that makes sense, and if you have any questions, please ask me. Bye!